Welcome to saitechinfo channel, my dear students. In this tutorial session, I'll be explaining about the problems that can be asked in wavelength, frequency, velocity, wave number, amplitude, and radiant energy. Let us consider the first one, that is wavelength. You know pretty well the wavelength is nothing but the distance between two. For example, before explaining this, let me illustrate a wave that can be represented in a very simple manner like this. Let me consider this is the x-axis and this is y-axis, and these are all the neutral points where this is the crust and trough. Let me say this is the circular motion, and that can be represented as a simple harmonic motion also. Here it is represented as a sinusoidal wave, that is sine wave, and here let me call this the origin, start from 0 degree. Now the object is moving in a circular fashion like this and reaches 90 degree. So this is the crust point, okay, 90 degree. And this can also be represented as pi by 2 radian. So this is pi by 2 radian, and this one is 180 degree, that is pi radian, and this part can be represented as 180 degree, which is nothing but pi radian. So for radian you can represent by C in the superscript of this pi. And this one is 270 degree, that is 1/2 pi, that is 3 by 2 pi radian. So it has reached 3 by 2 pi radian, and finally here it reaches 360 degree. So it means it has completed one full round in the simple harmonic motion, and in this case it has crossed almost 360 degree. Then it is getting ready for the next propagation, and in this case for the next circular motion. Okay, now, and this is 0 degree. Are you able to follow? So a one complete cycle can be represented as a wave, and that is why from this point and up to here, this can be called wavelength, which is almost equal to the circumference of the first circular motion, is it not? So that is wavelength lambda. And this lambda, what is the unit of lambda? After all, it is a length, it is a displacement, is it not? So it can be represented in meter. Okay, so the simple unit can be, let me say this is lambda, and its unit can be meter, and this can be represented in centimeter in certain cases. Centi means 10 power minus 2, is it not? So that is equal to 10 power minus 2 meter. Centi means 10 power minus 2, that is 1 by 100, that is 10 power minus 2 meter. And sometimes it can be represented as nanometer. So in that case, nano means 10 power minus 9 meter, right? Sometimes it can be represented as 1 Armstrong. Okay, so 1 Armstrong, it should be represented by like this A, and you can put a round like this. This is called 1 Armstrong, and this 1 Armstrong is nothing but 10 power minus 10 meter. 10 meter. So you should know all these representations of this lambda with various units. And sometimes if you want to measure this in terms of kilometer, that is kilometer km, that is equal to kilo means 10 cube, so 10 cube meter. Okay, it depends, right? Okay, now what are the possible problems based on this? And you can also discuss about decimeter, so you can let us mention this one also. Decimeter, deci means what? 10 power minus 1. So in that case, this is 10 power minus 1 meter. So in all these cases, you should be able to convert this into meter. So that is the important point. And let us mention about millimeter also. So milli means 10 power minus 3. So that is equal to 10 power minus 3 meter. So in whatever form they give in problem, you should be able to convert this into meter. So that is the point I want to stress here. And then now let us talk about frequency. What do you mean by frequency? That is number of waves passing through a given point in a given time, is it not? So that is frequency. Okay, for example, in this case, how many revolutions it can make, rotations per minute. So per minute means per minute RPM, rotation per minute. And if it is given in second, rotation per second, so like that. And in this case, number of waves. Okay, so one wave and two waves, three waves, four waves. So in a given time, how many waves are crossing the given point, and that is called frequency. Okay, right. Now let us discuss about the frequency. Okay, right. So frequency is represented as here frequency. That is represented by nu. This should be called nu. Okay, right. Now this is the number of waves or cycles, is it not? So number of waves. So when we represent this as circular motion, then it can be called number of cycles, is it not? Number of cycles or revolutions. Okay, so number of cycles. And then that passes through a given point. That is very important. That passes through. That passes through. Through a given point. That is called frequency, is it not? So its unit is per second. You can call it per second. In a given time means that is per second. And this per second can also be called hertz, H-Z, and it can be called hertz. Okay, hertz. Then what about velocity? Velocity we know. Okay, velocity. This is the displacement carried out in a given time. Displacement divided by time. So naturally its unit will be meter per second. Is it not? Meter per second. Then we should know the relationship between velocity, frequency. Okay, in this case there are, the velocity can be represented in two ways. That is, this velocity can be represented in two ways. One is the particle velocity, another is the wave, the light velocity, velocity of light or velocity of wave. Here it should be represented as c. That is, this is the light, velocity of light we can say, and this is the particle velocity. Okay, this is as an energy. So as light as an energy, so it should be represented as c. So when you represent this c, the velocity is 3 into 10 power 8 meter per second. So the light can travel in a second 3 into 10 power 8 meter. Okay, right. And this is the particle velocity. Now we are talking about this particle velocity, the light velocity nu, because we are dealing with electrons, so we can take it in terms of light. So velocity of light. So c, and that represents the velocity of light here, 3 into 10 power 8 meter per second, and this is nu, frequency, and lambda, the wavelength. And there is an equation that links all these parameters. What are those? That is, you got c is equal to nu into lambda, and this can also be represented as a v is equal to n lambda in case of particle velocity. Now let us focus on this. Okay, so these are all equivalent terms only, and this is particle velocity, and this is the what? The frequency. This is also frequency, the number of waves in a given second, and this is lambda. Now let us go with this c is equal to nu lambda, right? Okay, so and you should know another parameter called, that is, wave number, and this is represented by nu bar. This is called nu bar, that is lambda 1 by lambda. You can call it 1 by lambda. That is nothing but nu bar, that is wave number. Are you able to follow? Right. And this is nothing but the, as I already mentioned, the reciprocal of wavelength, which is nothing but wave number. Okay. Then, and let us consider this equation c. C, what is the unit? This is meter per second. I am now talking about unit. And what about nu? This is per second. Okay. And what about lambda? This is in meter. Okay, right. Then we should know something about amplitude. That is nothing but wave height. Amplitude. Okay, this is nothing but wave height. This can be represented as A. For example, let me consider this sinusoidal wave where, so it travels like this, and this height, wave height, is represented here as amplitude. Are you able to follow? Amplitude, take down. You can either call it the height of the crest or height of the depth of the trough. Okay, so I think for example, in this case I already explained CREST, crest. So crest, so this is the height of the crest. Okay, so this can be called amplitude, and also depth, okay, of the trough, which is also called A, right? Now, and what is radiant energy? Let me talk about that radiant energy. Okay, radiant energy. Radiant energy. So this radiant energy is nothing but, it is the energy transmitted from one body to another in the form of radiation. Okay, and in fact the decreasing order of radiant energy can be represented like this. For example, before that I think I already explained about this radiation energy, that is radiant energy, that is the energy transmitted. Okay, energy transmitted when from one body to another. Okay, another. And after all, this is in the form of radiations or rays. Okay, right. Now, as I already mentioned here, the cosmic rays. The cosmic rays have the energy greater than gamma rays. and that is greater than X-rays, and that is greater than ultraviolet rays, and that is greater than visible rays, visible light, okay, and that is greater than, that is IR, infrared rays, and that is greater than microwaves, which are used in communications, is it not, microwaves, and that is greater than radio waves. So you should note down this order, okay, the descending order of energy, radiation energy, and then you have, that is microwaves, then radio waves, and finally you can mention about the heat waves, okay. So you should note down this descending order of radiance. So from this you know very well cosmic rays have the highest radiant energy. Got it? Right. Now let me discuss about a simple problem based on this, okay. Right. Take down. A radio station broadcasts at a frequency of, so they have mentioned about the frequency 14 megahertz. 14 megahertz. Right. Calculate the wavelength. Of radio waves put out by the transmitter. Okay, put out by the transmitter. Now listen to me. So what are given here? Nu is given. So this should be converted into per second. Is it not? 14 into mega. Mega means a 10 power 6 hertz, which is nothing but 14 into 10 power 6 per second. Got it? And then lambda is asked. Now you know already, that is velocity is 3 into 10 power 8 meter per second. Now what is the equation? You have to use the formula here. C is equal to nu lambda, is it not? And what is asked here? Lambda. So lambda is equal to C divided by what? Nu. Okay. I'm sorry, that is lambda. It is, what is asked here? Lambda. So I must mention lambda here. So lambda is equal to C divided by nu. So this is the basic equation from which you can calculate. Now just apply what is C? 3 into 10 power 8 and put the unit simultaneously, meter per second, divided by, what about nu? Nu is given here as 14 into 10 power 6. Okay, so you can put per second. Now strike out seconds, per second. So you will get the value in meter. Okay, so this 10 power 6, 10 power 8, so 10 power 2. So the answer is 3 by 14 into 10 squared meter. Okay, so you can further solve it and you will be able to get the answer, that is 21.4 meter. Okay, so you can check this. So this is a very simple sum. This is the answer. So what are the possibility of asking question based on this equation? That we will study, and this is called the what you call the model problem mapping. Okay, shall we study this? Let me take the simple equation. C is equal to nu lambda. This is the original equation. Now straight away they can ask what is C value. So we know already the constant, and they may ask what is nu. So new by giving the value lambda. In that case you can find out what that is. C, you have to interchange C divided by lambda. So this is type 1. Type 2, they can ask, for instance, that they may give you the frequency and ask lambda. So what is lambda? Lambda is equal to C by nu. So this is another one. What is the third type they can ask? Probably they can compare two situations. Okay, so in that case we know very well that is C is equal to nu into lambda. Let me put like this. Nu is, according to this equation, C by lambda. Is it not? We know already C is constant. When you introduce constant, now you can bring this as proportionality. So 1 by lambda. Okay, so let us consider two different situations. For example, condition 1, nu 1. In that case it is proportional to 1 by lambda 1. Similarly, lambda and nu 2 is proportional to 1 by lambda 2. Probably by giving two parameters they may ask the third one. For example, this is the fourth model. I can suggest that is nu 1 divided by nu 2 is equal to 1 by, when you divide two proportionalities it becomes equal, and therefore 1 by lambda 1 whole divided by 1 by lambda 2. So it means that is lambda reciprocated, so lambda 2 divided by lambda 1, that is equal to nu 1 divided by nu 2. So likewise they can ask some proportions and compare. Okay, so this is another style they may ask. And similarly you may have another approach. For instance, as a fifth one, now I am taking that is like lambda, that is they may compare with the two different that is values of lambda also. Okay, so you can interchange it, okay, and get the same one. So either way, that is they may ask for instance what is lambda 2. So in that case what you can do, based on this you can proceed. Is it not? So lambda 2 means, and you have got this nu 1 nu 2, so nu 1 divided by nu 2 into what? Lambda 1. So this is the way you can achieve the answer. Okay, so likewise in various ways a simple equation can be asked in different forms, and wherefrom you can be asked different problems also. Okay, so is it clear? So just try to develop various types of problems based on this, and just go through the standard reference books and you may get plenty of problems based on a single equation. Okay, so thank you for watching this video.